Today, let us focus on the fundamental routing protocols. We will see the practical application of dynamic routing protocols in the Cisco packet tracer. So in this experiment, we will explore three prominent interior gateway protocols: RIP, OSPF, and EIGRP. We will see a step-by-step process for configuring them, and we will verify the connectivity. So routing protocol is a set of rules that enables routers to communicate with one another and exchange network information. This allows each router to build a routing table, which acts as a database to determine the optimal path for data packets to reach the destination. These routing protocols automate the process of finding the most efficient routes and adapting to the network changes. So for the demonstration, I have designed a simple network topology. This setup consists of three routers: R0, R1, and R2. Each router connects to a local network comprising a switch and a host PC. For example, R0 connects switch 0 and PC 0 over a LAN. And the network address for the first LAN is 192.168.10.0. Similarly, R1 connects LAN 2 with network ID 192.168.20.0, and R2 connects LAN 3 with the network address 192.168.30.0. The routers are interconnected via serial cables to form a wide area network. So before we configure any routing protocol, ensure that all interfaces on your routers are correctly assigned with IP addresses and have brought up using the no shutdown command. If you are not sure about how to establish serial connection, please watch the previous videos. So we configured R1 to have two serial ports. R0 connects to R1 on the serial port 3/0 with IP address 1.1, and R0 connects to R2 on the serial interface 3/1 with the IP address 192.168.2.1. Similarly, the gigabit Ethernet port on the router connects to the switch and the interface with IP address 192.168.10.1, the first usable IP address in the first LAN. So let us begin with RIP, a distance vector routing protocol. RIP operates on a simple metric called the hop count. Hop count is counted each time a packet passes through a router. Usually the maximum hop count is set to 15, which means 16 or more hops being considered as unreachable destination. RIP sends its entire routing table to its neighbors every 30 seconds per se, which can be inefficient on large scale networks. So to configure RIP, first use the router RIP command on the router R0. We have to repeat this on all three routers. Configure terminal. Let us remove any routing protocols as of now. So let us test what routing protocol is being used as of now. So show IP protocols. You can see the protocols are the routers are currently using the OSPF protocol. Now let us remove it. Configure terminal. So we have to enter the global configuration mode. Then no router OSPF 1. Now you can go back to the global configuration mode, sorry, the privileged mode, and then run the command show IP protocols. So right now there are no routing protocols that are implemented on R0. So let us also remove the routing protocols, if any, on R2 and R1. CLI enable no router OSPF 1. So as of now, OSPF 1 is being implemented by router 2. So enter the global configuration mode. Then no router OSPF 1. So this removes the OSPF configuration on router 2, R2. So let us verify it. Show IP protocols. So now no routing protocol is being implemented on router 2. Let us also remove any routing protocol on R1. R1 also implements OSPF. We will remove it. Enter the global configuration mode. Now say no router OSPF 1. Now none of the routers are implementing any routing protocols. Let us verify the connectivity. So 10.2 is the IP address of PC0. 30.2 is the IP address for PC2. 20.2 is the IP address for PC1. Now let us test the connectivity from PC1 to PC2, sorry, PC0 to PC2. So ping 192.168.30.2. So this should be unreachable because none of the routers are implementing any routing protocols. So does 20.2. 20.2 is also not reachable from PC0. Now we will begin with routing protocol RIP, routing information protocol. So RIP is a distance vector routing protocol. To configure RIP, first use the router RIP command on all the routers. You can go to the global configuration mode. Router RIP. This command initiates the RIP routing protocol on the router. It transitions the CLI into router configuration mode specifically for RIP. You can see the change in the prompt. Next, we specify the version 2 to ensure support for modern classless routing. Otherwise, RIP works only on classful addresses. So we will specify version 2. Then we use the command network and the network address configured on the router. So all three network addresses that are configured on the router 0. So network 192.168.10.0 is configured. So does 1.0 and 2.0. So this command is used for two reasons. It enables RIP on interfaces within that network range and advertises that network to uh, the neighboring routers, and also the no auto summary command. This is essential to prevent automatic route summarization, which can cause connectivity issues later. Anyhow, by default, Cisco routers often run RIP version 1, which is a classful protocol, and it does not support variable length subnet. So we use version 2 to support classless addressing. Next, we advertise the networks that are configured on router 0 to its neighbors for say R2 and R1. Then the auto summary disables the automatic summarization of routes at major network boundaries. So this will ensure all subnetworks, if configured, are properly advertised within the VLSM. Then you can go back to the global configuration mode and then say show IP protocols. You can see now R0 implements RIP protocol, and it advertised three networks: 1.0, 2.0 and 10.0. All three are configured on different interfaces on R0. Now repeat the same on the remaining two routers. Enter the global configuration mode, router RIP version 2, network. So on R1, there are three networks that are configured: 1.0, 3.0 and 20.0. 1.0, 3.0 and 20.0. Next is the no auto summary. And then exit. Repeat the same on R2. Configure terminal. Then router RIP version 2, network. R2 is also configured with three networks: 2.0, 3.0 and 30.0. Exit. So now I'll go back to PC0's command prompt and test the connectivity. See now 20.2 is reachable from 10.2. So does 30.2. 30.2 is also reachable from 10.2. Now the routers have advertised the networks that are configured on them using RIP. So the end devices, the PCs, are able to reach each other. Next, we will see the configuration of RIP on R0. So show IP protocols. So this will show you which routing protocol is active on the router. You can see that RIP is active on the router, including its version, update timers, and then which networks are being advertised. You can also see the uh, routing table entries for the networks 1.2 and 2.2. Show IP route. You can see the labels R, the entries with label R indicates that they are populated using the RIP protocol. C is connected, label C is to indicate connected, and L is for local. So this is on R0. R0 knows that 3.0 is connected via 1.2 on the serial interface 3/0 via 2.2 and the serial interface 3/1. You can also test the routing table entries on the remaining routers to see how the networks are learned from the advertisements. Now let us remove the RIP configuration to configure another routing protocol. So we will enter the global configuration mode. Then no router RIP. Show IP protocols. You can see nothing. Show IP route. Now you can see the entries in the routing table labeled R are removed. There are no entries with label R, which means RIP is inactive. Now if you test the connectivity from PC0 to any other PC, it won't be successful. See, the destination is unreachable. Let us also remove the routing protocols configured on R2 and R1. No router RIP. And on R1, no router RIP. So you can verify the change after disabling the old protocol. The devices will no longer be running the RIP protocol, and the routing tables are updated accordingly. I mean, the entries labeled R will be removed. You can also check the active protocols using the show IP protocols from the privileged mode. The output should no longer list the protocol you just removed. So now let us configure the second routing protocol. The second routing protocol is OSPF. OSPF stands for Open Shortest Path First. This is a link state routing protocol. OSPF is more scalable than RIP and uses a cost metric based on the interface's bandwidth to determine the best path. Unlike RIP, OSPF divides a network into areas to improve efficiency. To configure OSPF, we use the router OSPF followed with a process ID command. So enter the global configuration mode. So we use the router OSPF with a process ID. Process ID can be any random number. This process ID is a number that is locally significant and can be used to distinguish between multiple OSPF processes running on the same router. Next is the network address network, and the network address is on R0 or 10.0, followed with the wildcard mask. The wildcard mask is the inverse of the subnet mask. All routers must be configured within the same area 0. So the wildcard mask would be 0.0.0.255, and let us choose the area 0, the backbone area network. So is for the other two networks 1.0 and 2.0. All routers in the same area must have matching area IDs for their connected networks. Area 0 is considered as the backbone area. Let us repeat the same on the other two routers. R1, router OSPF1, and then network, the network address. R1 has 1.0, 3.0 and 20.0. Wildcard mask 0.0.0.255 and area 0. 3.0 is the second network. And 20.0 is the third network. You can see the serial interfaces are coming up once you configure OSPF on both sides of the serial link. The link starts coming up. router. On the third router OSPF 1 network 192.168.2.0 0.0.0.255 area 0. The second network is 3.0. You can see the interface has come up. And the third network is 30.0. Now you can test the connectivity from PC0 to 30.2. See, 30.2 is reachable. So does 20.2. All three PCs are able to reach each other. You can run the command show IP protocols. So this will show you which routing protocol is active, OSPF 1, and which networks are being advertised, 10.0, 1.0 and 2.0. Show IP route will show you the entries in the routing table. You can see the entries labeled O are because of the OSPF routing protocol. So the routes that are learned from the protocol are identified by the letters R for RIP and O for OSPF. Once you configure the new protocol, new routes will appear with the corresponding letter. So there is a protocol specific command that you can run, show IP OSPF neighbor. So this will show you the neighboring networks 30.1 and 20.1 on the other side of the serial interface. Now let us remove OSPF configured on all three routers. Global configuration, no router OSPF1. Repeat the same on R1 and R2. So now we removed the routing protocol OSPF from all three routers. Now let us move on to the third protocol, EIGRP. EIGRP stands for Enhanced Interior Gateway Routing Protocol. It is an advanced distance vector protocol. EIGRP is a Cisco proprietary protocol that calculates the best path using a composite metric based on factors like bandwidth, delay, reliability, and load. So it is not just based on one metric, it is a combination of several metrics. So the configuration begins with router EIGRP. followed with an autonomous system number. Anyways, the autonomous system number must be the same on all routers. If you want to participate in the same EIGRP routing domain, the router should share the same autonomous system number. So let us choose the number 10. If the autonomous system numbers don't match, the routers will not form a neighbor relationship. They will be acting independently. Next is the network address 192.168. We are on R2. So R2 has three networks: 2.0, 3.0, and 30.0. Similar to RIP, the no auto summary is essential for preventing root summarization. So this no auto summary is a best practice in modern network environments to avoid any conflict. Let us repeat this on the remaining two routers. We are on R1, and R1 is configured with 1.0, 3.0. See, the interface starts coming up, and 20.0. Repeat the same on R0. 1.0, 2.0, and 10.0. Now you can test the connectivity. See, 20.2 is reachable from 10.2. So does 30.2. Noticing the differences in routing protocol, the most effective way to see the difference is by examining the routing table and by using the protocol specific verification commands. So you can go to the privileged mode and run show IP route. See, the entry is labeled D. D is the label for EIGRP. You can also run the protocol specific command show IP EIGRP networks sorry, neighbors. So you're on R0 and you can see the IP address, the interfaces that are connected, the round trip time, the sequence numbers, and so on, the counters, and so on. Each routing protocol has distinct characteristics and is suitable for different network needs. RIP is simple for small networks, while OSPF and EIGRP are more scalable for larger and complex environments. Okay, thank you.